What's up, everybody? How you doing? It's Mr. Doodle Math here, and we're going to talk about some more percent problems. But this time, we're talking about percent in relation to sales tax and a sale price, right? Discount and all of this stuff, right? So let's take a look at it. Remember in the last video, I showed you this equation: A equals P times B, right? If we gave A, P, and B like an actual name, we could use this for like what we're about to do right now, and then after that we'll just really just do the math. All right, if A is the sale amount, A can be the sale amount, right? Sales, let's call it the sales tax amount. Sales tax amount. P is the tax rate, and B is the price, right? Or the item's cost, right? If we look at a problem like this, look, if we want to know what the sales tax amount is, we want to know the sales tax amount, we'll multiply the tax rate by the cost, right? And that gives us the tax rate. And then once we find out what the sales tax amount is, we add it to the actual cost of the item to figure out how much we got to pay, right? And so that's the math involved, right? So that's the formula. A equals PB. A being the tax amount, P the percent, right? B is the cost, right? Let's take this into mind and let's do an example, right? So look, suppose the local sales tax rate is 7.5%, right? And you're trying to purchase a bicycle, which is what I'm trying to do for $894. How much will the taxes be, and then how much will I pay for the actual bike, right? So first things first, you want to label what you have, right? First things first, label what you have. So based on this, we got the percent, 7.5%, and the price of the bike was like $864, $894. I actually want, yeah, did I mention that? I want a bike. I want a bike. This is a bike. This is a low-end bike, right? So, but anyways, so we want to know what the sales tax is going to be, right? And so let's do the math. So to be the taxes, which is 0.075 times 894. That's gonna let us know what our sales tax is. So here we go. 0.75 times 894 gives us $67.05. $67.05 is what the sales tax is gonna be. So this is how much we're paying in taxes, right? From these taxes, to find out the price of the bike, right, what you're gonna actually pay, you'll add this amount to the price of the bike. So so the total cost is A plus B, right? A being the sale tax plus the cost. So whatever the cost is, multiply that. I mean, we add it to that. So here it is 6705 plus 894. Plus 894. So that means that I'm paying $961.05, right? That's what you're doing when you're dealing with like sales, when you want to know what the sales tax is and how much you're going to pay, right? Let us look at an example when we have like there's a discount, which is kind of what's finna go on. Like we're in this Black Friday season, right? Black Friday, that means you're taking a percent off, which is gonna be the exact opposite, right? So you got same thing, A times PB, A equals PB. This time A is gonna be the discount amount. Discount amount equals the percent times the original price, right? The original price or the cost. Price, can't spell right now. All right. So the percent, this percent is the discount amount, though. Discount. Oh, discount. All right. So you multiply. So it's just like the last problem where you're multiplying the percent by the percent given, the rate by the cost. It's going to give you how much you you're discounted. Discount means off, right? You subtract it, minus. All right, so basically what you're gonna do is you're gonna calculate what the discounted amount is, what the amount discount the percent off is, and then subtract it from the total cost. So let's look at an example. All right, so check this out. You're looking at a computer. Its original cost is, the computer cost $1,460, right? $1,460, and it's on sale for 15% off. Right, 15% off. They want to know what the discount amount is, and then they want to know how much you're gonna pay. All right, so let's do the math. Here we go. So it's gonna be the discount percent, 0.15 times 1460, 1,460. Right? Oh, I cannot see my calculator. 1460 times 0.15. That means that you're gonna take off $219 for the price of this computer, right? So this is the discount. I'm sorry, I cannot like write or spell right now. Discount amount. That's the discount amount, right? You're gonna take this $219 and you're gonna subtract it from $1,460. So it's $1,460 minus $219 to get your new price, right? Minus $1,460, and you're gonna get $1,241. So now at a 15% discount, you're gonna pay $1,241 for your computer, right? It's $219 off, right? So what we just looked at is two examples. We're looking at an example of sales tax, right? You apply the sales tax. You take and so we looked at a sales tax and we looked at a discount. So you apply, or so you add a sales tax and you subtract the discount. Okay? You add a sales tax and you subtract the discount. And that's pretty much it. One other example. What percent increase, percent decrease, right? Percent increase, percent decrease basically talks about the amount that something the change in the percent, right? So if there's a percent increase, that means it's going up. If percent decrease is going down. So it uses the same kind of formula, right? Where you're looking at an original price, an original amount, and a secondary amount, right? An initial and a final, right? For percent increase, the final goes first, the original goes second. For decrease, the original goes first, and the decrease goes down. Is second, right? Because we gotta look at positives and everything like that. So here's the basic formula. So percent change, that's what we're gonna call it. Percent change is going to be, right? For a positive percent change, it's gonna be final amount minus original amount over the original amount, right? So that's for increase. For percent decrease, you're gonna do the original amount minus the final amount all over the original amount, right? Reason being, right? Why do you think you put the final first and original second here, but you put the original first and the final second here? Why do you think that? Right? Take a moment to think about that. Pause your camera. Take a moment, not your camera. Pause your video, and then think about that for a moment. Why is the final first and original second here? Why is the original first here and the final second here? Okay. All right. So let me tell you. All right. When you have a percent increase, that means that the original goes up. So in theory, the final is bigger than the original, right? And so when you do this math here, the subtraction, you still end up with a positive number. Same here. If there's a percent decrease, that means that what it went down. So the original is going to be bigger than the final amount. That's percent decrease. All right. And so you're going to subtract the final amount from the original amount to keep your numbers positive, right? That's what it's all about. All right, so let's calculate one of these, right? Let's see. Percent increase, percent decrease. All right. All right, let's look at this. In 2000, the world population was approximately 6 billion. All right. The projections according to 2150. All right, so look. So you got optimistic growth and pessimistic growth. All right, so there's this table here that's going to show us the population, the world population projections from 2000 to 2150, right? And so there's three types of projections. You got a high projection, a medium projection, and a low projection. Okay, I'm going to show you this, and I'm going to put it in the screen here, right? And so based on the data, you have optimistic growth and pessimistic growth. High projection is optimistic growth. Low projection is pessimistic growth, right? So what they want to do is they want to find a percent increase in the world population from 2000 to 2150, and then using the high projection data, right? And then they want to do it using the low projection data. All right, so again, all right, so if we want to look at the percent increase of the world population from 2000 to 2150 using a high projection data, it says this. In 2000 it was 5 billion. It was 6 billion. In year 2000 it was 6 billion. The high projection says that in 2150 it's going to be 30 billion. Okay? So which formula do we use? Do we use this one or the top? Yes, we use the top because this is a percent increase, right? So percent increase says I've used the final amount minus the original. So it's going to be, they said 30 billion. So we'll put these in terms of billion. So it'll be 30 minus 6, the original amount, divided by 6, right? That's going to give us our percent. All right, let's do it. Let's do the math. So 30 minus 6 is going to give us 24. 24 divided by 6. 24 divided by 6 is going to give us 4. All right, so it's going to give us 4. So bop equals 4, right? So this is a 4%. No, it's not a 4% increase because we also have to do this last part, which is multiply by 100, right? Because we have to change it from, we got to change it from an actual number. Like this is the decimal form. We got to change it from a decimal form to an actual percent. All right, so it means we're going to multiply this by 100, and we're going to get 400%. So there's a 400% increase in the population if it goes from 6 billion to 30 billion in 150 years, right? Let's look at the percent decrease now, right? Percent decrease says that like using percent decrease formula, so we're gonna look at the low projection data. They said that in 2000 you're gonna have 6 billion, right? So percent decrease, the formula goes original minus final, right? So that's going to be 6 billion in 2000. The low projection says that it's going to be 4 billion in 2150. So it's going to be 4 billion all over the original, right? Let's look at this percent decrease, right? Here we go. So it's going to be 6 minus 4, which is going to give us 2 divided by 6. 2 divided by 6 is going to give us like 1/3, which is 0.33 repeated, right? Multiply that by 100. That means it's going to be a 33.3% decrease from 2000 to 2150, right? So so that's what you're dealing with percent increase and percent decrease, right? So let's review, right? So far, so we talked about applying sales tax. We talked about applying sales tax. We talked about discount amount, and then we talked about percent increase and decrease, right? For the sales tax, you're gonna multiply the tax amount. First, you gotta change it to a decimal, right? You gotta change the percent to a decimal. That's the first thing you gotta do. Change percent to the decimal. Then you gotta multiply by the cost. Once you do that, you get the sales tax, right? Then you add the sales tax to the cost. That's what we did, right? The second thing was the discount amount. Same thing with the discount amount. You multiply that discount percent, that discount into the cost, and then you subtract it, right? Because discount means you take it off. Percent increase and percent decrease, what you're doing essentially is for the increase, you're going to subtract the original amount from the final amount, right? Because the final amount is bigger. Then divided by the original, multiplied by 100, you got your percent, right? For a percent decrease, the original goes first, the final goes second, because it's decreased, the final is smaller, right? And then you divide, multiply by 100, you get that percent, right? And so look, that's everything that you need to know about percent for the most part, right? Multiplying it, either finding a percent where we got to do percent increase, percent decrease, or adding or subtracting a percent based on a tax rate or a discount amount, right? So that's all we want to talk about in percents today. If you have any more questions, comment below. If you've liked this video, if you like what I'm saying here and you like the way I teach, don't forget to like and subscribe. And hope to see you next time. Mr. Do the Math.